At Hewlett-Packard Enterprise, we design our own HPE custom iLO 5 silicon. Burned into the iLO 5 chip is a digital fingerprint of the iLO firmware. This is the basis of our silicon root of trust and is how we are differentiated from other terms you may hear, like hardware root of trust. Because we make our own silicon chip and our own firmware, we are able to create this bond that cannot be broken between the two. The silicon root of trust provided by the iLO 5 chip is one of the foundations upon which the world's most secure industry standard servers are built. We start with the brand new iLO 5 chip with the silicon root of trust burned into it. Then we tie into that the iLO firmware code. The chip itself verifies the iLO 5 firmware and decides whether or not to run it. The key differentiator is that the decision is made inside the secure memory of the iLO 5 chip, where the silicon root of trust determines whether or not to run the firmware. If a hacker inserts a virus or compromised code into the server firmware, it changes the configuration of the firmware, alters the bits and bytes, which makes the firmware not match the digital fingerprint embedded in the silicon. Once the iLO 5 firmware is verified by the chip, the iLO firmware will then verify the UEFI BIOS. Now we can begin to see how this silicon root of trust is building up. Next, the system programmable logic device firmware is verified, followed by the innovation engine firmware and the server platform services firmware, sometimes referred to as the management engine. These 5 essential firmware components are referred to as our secure start base, and all 5 must be verified or the server will not power on. Once the server is allowed to power on, our UEFI Secure Boot technology verifies the option ROMs and the OS loader. But what happens if all 5 of the essential firmware components are not verified? Included in the server on our unique non-volatile flash storage, sometimes called the NAND, are factory-installed known good copies of those 5 essential pieces of firmware. These are put into an install set called the recovery set. If any of the firmware fails its secure start verification, then iLO has the ability to securely recover that firmware before the server is allowed to power on. Here you see the iLO 5 firmware retrieving the backup copy of the system ROM. iLO then verifies the integrity of the recovery firmware on the NAND before securely reprogramming the system ROM. The silicon root of trust is the key differentiator with HPE Gen 10 servers and iLO 5. This unique digital fingerprint establishes a secure, trusted chain, allowing HPE to monitor these 5 essential firmware components to protect, detect, and recover your infrastructure.